In an era of new super heavy lift rockets, there are also some new small launch vehicles working for their seat at the table. One of those is Vaya Space's Dauntless rocket. It's a 35-meter or 114-foot tall two-stage vehicle powered by a series of Vortex hybrid engines. On July 15th, an important delivery came from California for Vaya Space, the first full-size liquid oxygen tank shell that will be used for pathfinding tests.
We've been working on the design of the Dauntless vehicle for almost 2 years now, ever since we did our flight tests out in Mojave to prove out the last questions we had on the basic engine technology. And so what we're seeing now is our dream, this, come to life. It's an amazing moment for the company.
The whirring heard in the background is a 3D printing machine that is molding one of the Vortex hybrid engines. Vaya Space says once they're up to their full production rate, they will be able to build one of these engines about every 2 days. Taking a look at the Dauntless rocket itself, it's a two-stage vehicle, so you've got the upper stage here, and the first stage, which looks a little bit different than some of the other rockets that you see flying right now. These are essentially test articles for the solid propellants that will be strapped around to the side of what will be the oxidizer tank. So what we were showing you earlier, this Pathfinder shell over here that will be wrapped, that will eventually look like this. The tank will then be wrapped with carbon fiber like the engines.
Basically, the shell's job is to contain the liquid oxygen and not allow any to escape. The overwrap on the outside is really just to strengthen everything up and actually make sure that it contains the internal pressure and the actual launch loads of the vehicle itself.
Before they were ready to move to wrapping work on this full-scale tank, engineers at Viaspace first began with this smaller mock-up. Christopher Hayes says there was a lot of work involved with scaling up.
That one is much easier to making this one. We learned a ton in actually manufacturing this one in terms of basically the stiffness of that one. Since it's such a small thing, it's very easy to handle. This one we had to figure out how to tie all the different pieces that are going together, as well as centering it. There's also the fact that it's really big. So with that one, you can easily reach over onto it and just lay up. Here, you can't access the top, so you actually need to build a bunch of tooling and scaffolding to get up there, and so that was definitely a big challenge.
This tank comes from a partnership with a California-based company called Scorpius Space Launch Company. Senior structural engineer Michael Morey says they've been working on the design for about a year.
There's a little bit of downtime in between, but with that, we were able to kind of fine-tune the process, get going with change the processes from adapting to the lunar tanks to this type of tank, which is a much larger and much more demanding, I would say, project than it would be for the lunar tanks, just based surely on the size of it alone.
When Morey says lunar tanks, he means those Pressure Max tanks used on the Intuitive Machines Nova C lander that launched to the moon in February 2024.
Originally, we were Plan B. They had built their own original tanks ahead of time. They weren't quite working out as well as they wanted, but they had us as a Plan B. Once our tanks were built and being manufactured, and then they passed most of their tests, they found out, let's make it Plan A now. So our tanks became installed into the Nova C lander.
Seeing that technology go to TRL-9, to actually fly, to actually be on the moon, it was exciting and it was a relief all at the same time. That's one check block. I know I can trust my tanks because they've already been there and done that.
Viaspace's Chief Operating Officer Rob Fabian says they're currently working towards their first launch sometime in 2026. He says in 2024, they will mostly focus on their engines.
The rest of 2024 for us is two things. First, engine testing. We have an entire series of stair-step approaches to engine testing for basic characterization and then adding in the turbo pump and adding in the thrust vector control until at the end of that test series, we're testing a single flight representative motor. At the same time, we're fleshing out all the rest of it. The structural piece, building and testing to make sure that the tanks can actually do what our designs say they can do. The avionics is going. We've got quite a bit of work going on the battery systems, on our flight safety systems, and our guidance and navigation algorithms. So this is the busiest time that the company has ever had, and we're continuing to grow while we do it.
Much of that engine testing will happen just a few miles from their manufacturing facilities at this relatively new test stand.
So we're going to be basically qualifying a similar engine, but we won't be testing the final engines. Because the way that our engines work, they're hybrids, they're a little bit different than liquids or even solids. We can't really test it. We're going to have to basically qualify the design with a lot of development hardware ones, and then we'll verify it on a vertical test stand, and we'll do some flight-like engines, and we'll test those, because those will essentially just have a slightly thinner overwrap, have a slightly lower safety factors, a few things like that. But for the most part, we're going to be qualifying the design, and then once the design's qualified, we're basically going to be throwing those engines on and going.
The Dauntless rocket will be launching at a site these days known for landings.
Stage 1 landing burn.
That's Space Launch Complex 13, also referred to as Landing Zone 1. Fabian says Viaspace and Phantom Space began talking about a joint launch pad well before the US Space Force discussed making sites along Missile Row available to new commercial launch companies.
Mark Lester, their COO, who's in charge of the launch pads on their end, and I actually knew each other before from when he was up at running Kodiak Spaceport. And so we've had a great working relationship between the two companies. So the first thing we did was set up the business relationship. Nothing's real until the paperwork's in place. That's in place now. And then immediately we started talking with SpaceX. And the local SpaceX team has been very cooperative in this, helping us get the information that we need and working through them on how we do the transition so that they get their needs met as they build out the new landing pads for the Falcon 9 booster without giving up access to the current ones in the process.
That process will really kick into gear around midsummer of 2025.
The Space Force has given us a promise of a lease starting at the end of January of next year rather. We're not going to need it quite then. So looking at the environmental assessments and the initial architectural designs, we're not going to need it till midsummer, and that plays nicely with SpaceX. We've got an agreement in place between the three companies that allows them to overflow and continue to land before we start construction.
He says the biggest hurdle in front of them right now will be locking in on their engines.
Because that's our unique technology. That's the stuff that is not from somewhere else or done somewhere else. Guidance, navigation, and control is proven. We're using commercial off-the-shelf avionics, stage set systems, fairings. We're working with Scorpius on the tanks. These engines are ours. Now, that said, we've spent the last 7 years refining a physics-based model of how these engines work at any scale. And we've done 120 plus tests of it from 150 pounds of thrust to 5,000, soon to be 22,000. And so we have a really solid understanding of how that engine works. But seeing it at that 22,000 pound thrust test level and characterizing its actual real performance, that's the heart of what we're doing.
Reporting in Cocoa, Florida for Spaceflight Now, I'm Will Robinson Smith.